Welcome to AFrame Lesson 4.3. In this video, we're going to explore how we can add physics to our VR world through a library called AFrame Physics System. In this system, we will explore how we can add an additional attribute to our components to specify whether these components should be rigid, static, or should they be movable, dynamic. We're also going to explore another code segment that has been deprecated, but is still very useful for our VR world, which is called a kinematic body. So let's get to it. So just to kind of orient you to what we have so far. So we have a couple of planes to represent floors at two different levels. We have a box, which we want to make it immovable. And then we have a couple of components that we want to be able to allow them to react to the physics in our world. Let's go ahead and pop this open to a new page. And just to kind of see, here's our box, here's our plane, and here are our shapes up in the sky. And if we go over to the edge, we should be able to see the other plane as well. All right. So let's see how we could go ahead and add some physics to our world so our components can react to each other as well as to us. So as I mentioned, if you Google AFrame Physics System, you'll probably get the same link. And it'll take you to this GitHub. Now, if you scroll down a little bit to the installation part, you'll notice that there's two types of installations. There's two types of drivers we could use with our physics engine. Again, it'll be left up to you to decide which one to use. I'm going to demonstrate using the Canon.js driver with our physics system. So I'm going to click on this link. And what we need is this right here. We need a link to that library of the physics system that uses the Canon driver. So let's go ahead and add that to our world. And let's read a little bit while we're here. So scrolling down a little bit to the section that says basic, and you can even get a peek at it in the next section where it says components. There's essentially two things you specify through the physics system, which is called static bodies and dynamic bodies. Let's start off with the dynamic body. And let's make our first box, the orange box, dynamic. Now, just to go back here, kind of show you, those are our shapes. Here's the box, here's a sphere, here's a cylinder. And let's go and refresh the page and let's see what happens to the box. All right, so the first thing we saw is that the box just kind of went through everything. That's because it had nothing to stop it. That is the purpose of our static body. So notice that they apply a static body to the plane. So let's add that. And let's see how the box reacts now. All right, so you'll notice that the box did not go through the floor and it even bounced. But notice it's kind of like sitting inside of this other red box. Again, in the real world, that wouldn't happen. So let's add a static body also to our red box. And let's see how that affects the physics between these two components. Okay. So notice, because the red box is now static, the orange box did not go through it. And it didn't go through the floor because our floor is also static. All right, so let's explore adding the dynamic body to our other two shapes that are up in the sky. So that's our sphere and our cylinder. All right, so let's say refresh. And let's see what happens. Okay, so you can see here a couple of things. Hopefully you noticed that the green sphere bounced a little bit, but then you also notice that because the sphere landed on top of the orange box, it further pushed it off the edge, and quite honestly, it fell off of the yellow edge, the yellow plane as well. So now let's talk about us, because let me demonstrate this before we go any further. Notice we're able to walk through the red box and the blue without really affecting those components. again, in the real world, everything affects something else. So for this, we're going to add another library, which is this one right here. Now, as I mentioned, this is an older code segment for an older version of the physics system, but it still works for what we're doing. And let's go back here and just save ourselves a little bit of time. I'm going to add a couple pieces of code. Actually, let me add these first. So I'm going to add links to a couple of JavaScript files, and I'll explain them as we go through. And let me add this. So what we've done here is that we've created a camera rig where our camera has that kinematic body. And I'll explain to you what that essentially means here in a second. But then I also have an entity that's going to handle the movement of our camera. So our camera is sitting inside of another entity that's actually going to respond to us moving with the keyboard. So a kinematic body is kind of a combination of both static body and dynamic body, in that we will not be able to move through static bodies, and just like a dynamic body, we'll be able to affect other dynamic bodies. So again, probably the easiest thing to do is just see what happens now that we've specified our camera and specified this attribute of kinematic body. Okay, so oh, box went off, but I don't think it went off far enough. No, never mind. It missed the yellow plane too. All right, so let's see how we interact with this red box, which was static. So you'll notice now we can't go through the red box. Again, the red box is static, so we shouldn't be able to. Let's see this green sphere. Now remember, the green sphere is dynamic, so let's see what happens when we collide with the green sphere. And there we go. We were able to push it off the edge, and let's see. I think it, oops. All right, oh, you know what? This is actually a good thing to discuss. So I applied the static body to the green plane, but not to the yellow plane. So guess what? We fell through the floor and we just kept on going. All right, so let's fix that. So let's apply static body to our yellow plane as well. And you got a little bit of a hint of what's on the second level. So before we go refresh the page, now let's talk about these other two files. So in our script.js, this is actually being borrowed from an earlier video where I demonstrated how we can create a maze by simply creating an array of strings where we mapped out where things should be within the maze. We use a double for loop to kind of go through that array of strings, and we simply create new blocks wherever there's an X in our template up here. And you notice we're creating at negative 9.5, which is at that second level with the yellow plane. Let's take a look at the block. Because in a maze, you should not be able to go through the walls. So our blocks are essentially just boxes, but we've added the attribute of static body. So when we jump down to that second plane, we should be able to, go through the maze and not cheat, except for the fact that I added this additional event listener that when we click on a block, we simply remove it. All right, so let's go ahead and refresh. And let's see how this cylinder lands. All right, let's try to push the cylinder while we're here. See if we can push it off the edge. Oops, there we go. I find that the cylinder is very particular when working with the camera. Notice it does react, but it's very hard to push. Unlike a sphere, which we merely tap and it goes right off. So let's go ahead and, well, not follow the sphere all the way down. But you notice that the sphere did stop on the yellow, and just as we did. So here's our maze, created from blocks that have a static body attribute. So notice I can't go through the walls, just like the red block, the red box that was up in the green plane. All right, so we have to look for an opening. So here's an opening. Notice I'm able to go through the opening and kind of navigate through here to, wherever we want. Again, I can't go through the walls, But what I can do if I wanted to, I can click on the walls to create an opening and perhaps go this way. Now, granted, I'm not quite sure why I would want to go there. I actually want to try to get out of here. So let's click on some more blocks over here, create an opening, and now we can actually go through. And again, there's so many more things you could do with the physics engine, but these are some of the basics. So let's go back to our presentation and let's review what we've done. So in this video, we explored the A-frame physics system, which allowed us to specify an additional attribute of either static or dynamic to our components. Static bodies are rigid, meaning that they won't move, and objects that bump up against them will bounce back. A dynamic body are objects that will be affected by physics. So for instance, if you put an object dynamic that's high in the air and there's nothing static to stop it, it will fall until it finds that static component or possibly another dynamic component for it to bounce off of. We also saw an additional piece of code that we can add so that the camera can also be part of this physics system in our virtual world. By using this kinematic body, we were able to push dynamic bodies that we had in our world, and we were able to kind of prevent ourselves from sliding through the world when we hit a static body. We also saw that we cannot go through static bodies such as walls, which is also a very convenient feature to add to your VR world because you don't want people just going in through your houses. So hopefully you're excited about adding physics to your virtual world, and enjoy.